Hello, welcome to another video. Alright, so in this tutorial, I'll be providing solution to this nuclear and particle physics problem. Alright, so we have two questions. Now, the first question here reads, a stationary uranium-238 nucleus decays into a nucleus of thorium-234 by emitting an alpha particle. The chemical symbol for thorium is Th. So we are asked to write a nuclear equation for this decay. That is the decay of a stationary uranium-238 into a nucleus of thorium-234, okay, which loses an alpha particle. So we are asked to write an equation, that's a nuclear equation for the decay of uranium into a nucleus of thorium-234. So now, to set up the equation, all right, we need to understand why we have what we call uranium decay. Now, when uranium decay into a nucleus of thorium-234 by emitting an alpha particle, so what that means is that the uranium is going to lose, is going to lose alpha particle. And when it loses an alpha particle, it means that the mass number or the atomic mass of uranium-238 will decrease by 4 and its atomic number will decrease by 2. So that's what it means, for the element to emit an alpha particle. All right, now let's do the solution. So like I said, we want to set up the nuclear equation for the decay of a stationary uranium-238 into a nucleus of thorium-234 by emitting, that is, which loses an alpha particle. So we have the first question, okay, the nuclear, okay, we have the nuclear equation. So what is the nuclear equation? Now the nuclear equation would be, now we have a stationary uranium-238 which decays. So that means when the uranium is bombarded, okay, this is the atomic mass of uranium, and then we have its atomic number. So when the uranium decays, all right, it decays into a nucleus of thorium, and we are given here that the chemical symbol for thorium is what? Th. So which means we have the thorium, then the atomic mass of thorium is 234. So this is 234. Then now that means that the atomic mass of uranium decreases by 4. So when it decreases by 4, the atomic mass of thorium will be 234. Okay, now don't also forget that I said because it loses an alpha particle, so it means that the atomic number of uranium will also decrease by what? By 2. So which means that this is going to be what? 90. Okay, so it emits an alpha particle. So for alpha particle, we know that alpha particle, okay, may be represented with helium nuclei. So we have the atomic mass to be 4 and the atomic number to be what? To be 2. So this is the nuclear equation. All right, this is the nuclear equation for the decay of uranium-238 into a nucleus of thorium. And don't forget I said when the element loses an alpha particle, what that tells us is that the mass number of the uranium will decrease by 4 and the atomic number, that's its atomic number, will also decrease by what? By 2. And this is the answer to question A. All right, now the second question here is that we have the mass of the uranium nucleus is 4.0 multiplied by 10 to the negative 25 kilogram. Okay, after the decay, the thorium has a speed of 2.4 times 10 raised to the power of 5 meters per second. So we want to calculate the kinetic energy in mega electron volt of the alpha particle. Now, to calculate the kinetic energy in mega electron volt of the alpha particle, so let's first identify the parameters. We need to first identify the parameters. Now, we have here that the mass of the uranium nucleus is 4.0 multiplied by 10 to the negative 25 kilogram. Now, which means that the mass of the uranium nucleus, it is a stationary uranium nucleus that decays into a nucleus of thorium-234. So that means that the mass of the uranium, okay, Now B, okay, we have mass of uranium, okay, would be equals to mass of thorium, So that means that mass of thorium, let's say mass of thorium is designated with MTH. Now that will be equals to 4.0 multiplied by 10 to the negative 25 kilogram. So that's 10 raised to the power of minus 25 kilogram. Then also we have that after the decay, the thorium has a speed of 2.4 multiplied by 10 raised to the power of 5 meters per second. So that means that speed, which is the velocity of thorium, would be what? Would be 2.4, okay, multiplied by 10 raised to the power of 5 meters per second. That's the velocity of thorium. So don't forget, mass of thorium, okay, is NTH. Velocity of thorium is what? Is VTH, okay? Now, we want to calculate the kinetic energy of the alpha particle. Now, to be able to calculate the kinetic energy of the alpha particle, now let's not forget that kinetic energy is the energy possessed by a body by virtue of its mass and its velocity. So which means that to be able to calculate the kinetic energy of alpha particle, so we need to first find out the value for the mass of alpha particle and also the velocity of alpha particle. Now, to be able to calculate the mass of alpha particle, now because we know that alpha particle contains proton, alpha particle contains proton. We know that alpha particle is a positively charged particle, so it contains proton. So because it contains proton, okay, to calculate the mass of alpha particle, so it means it's going to be mass of alpha particle, okay, mass of alpha particle, okay, mass of alpha particle. So since it contains proton, okay, mass of alpha particle will be atomic mass of alpha particle, which is 4. Then we multiply it by the mass of proton. Now we know that mass of proton is 1.675 multiplied by 10 raised to the power of negative 27. So this is going to be 4 multiplied by mass of proton. 4 multiplied by mass of proton. Now, what is mass of proton? Now, mass of proton is 1.675 multiplied by 10 raised to the power of minus 27 kilogram. So, which means to obtain the mass of alpha particle. So, mass of alpha particle would be when we multiply the atomic mass of alpha particle by 1.675 multiplied by 10 raised to the power of minus 27. Now, don't forget, the unit is the what? Kilogram. The unit is the kilogram. So, when we multiply 4 by 1.675, okay, that will be 6.7. All right. So, this is going to be 6.7, okay, multiplied by 10 raised to the power of negative 27 kilogram. That is the mass of alpha particle. So, we have our mass of alpha particle to be 6.7 multiplied by 10 raised to the power of negative 27 kilogram. Now, don't forget, we want to calculate the kinetic energy in mega electron volt of the alpha particle. So, to be able to calculate the kinetic energy in mega electron volt of the alpha particle, okay, remember, to calculate kinetic energy, we need mass and velocity. Okay, now we have the mass of alpha particle. Now, to be able to calculate the velocity of alpha particle, here we have mass of thorium and also velocity of what? Thorium. Okay, then we have mass of alpha particle. So in this case, to be able to calculate the velocity of alpha particle, so we then employ the use of the principle of conservation of linear momentum. Yes, that is because we have after the decay, the thorium has a speed of, that means it moves with a speed of 2.4 multiplied by 10 raised to the power of 5 meters per second. Okay, so that means that by using principle of, that is, okay, now using principle of momentum. That is conservation of momentum. So we have mass of thorium, okay, multiplied by velocity of thorium equals to mass of alpha particle multiplied by velocity of alpha particle. Now don't forget that we want to find out the value for V alpha. So the value for V alpha, to be able to find the value for V alpha, now let's express V alpha in terms of mass of thorium, velocity of thorium, and mass of alpha particle. So we have velocity of alpha particle to be mass of thorium multiplied by velocity of thorium. Then we divide that by what? Mass of alpha particle. Mass of alpha particle. So we have velocity of alpha particle to be mass of thorium, which is 4 multiplied by 10 raised to the power of negative 25, then multiply by 2.4 times 10 raised to the power of 5, then all over the mass of alpha particle, which is 6.7 times 10 to the what? Negative 27, which is the mass of alpha particle. Okay, now multiplying 2.4 by 4, that will be 9.6. Okay, so this is going to be 9.6. Okay, 9.6. Then this is 10 raised to the power of negative 25, and this is 10 raised to the power of 5. So we combine the powers of 10. So this is negative 25 plus 5. Then all over 6.7 times 10 raised to the power of negative 27. Okay, so in this case, this will be 9.6 times 10 raised to the power of negative 25 plus 5. That will be 20. That will be negative 20. Okay, now we have this divided by 6.7 multiplied by 10 raised to the power of negative 27. Okay, so now what is 9.6? 9.6 divided by 6.7. 9.6 divided by 6.7. Now that would be 1.433. Okay, so this is going to be 1.433 times 10 to the, now when we bring negative 20 here, it's going to turn to plus 27. Okay, so negative 20 plus 27, that will be 7. So this will be the velocity of the alpha particle. All right, so the velocity of the alpha particle is 1.433. okay, 1.433 times 10 raised to the power of 7 meters per second. That's the velocity of the alpha particle. Now remember, we want to calculate the kinetic energy in mega electron volts of the alpha particle. Okay, now to calculate the kinetic energy, okay, to calculate the kinetic energy, now we have the mass of alpha particle. Now we have m alpha. Mass of alpha particle is now 6.7 multiplied by 10 raised to the power of minus 27 kilogram. Now velocity of alpha particle, the velocity of alpha particle is 1.433, okay, multiplied by 10 raised to the power of 7 meters per second. Now kinetic energy, okay, the formula for calculating the kinetic energy, okay, would be 1/2 multiplied by mass of alpha particle, then multiplied by velocity of alpha particle raised to the power of 2. So we're going to plug in the value for V alpha and M alpha into this equation. So this will be kinetic energy is going to be 1/2 multiplied by the mass of alpha particle is 6.7 multiplied by 10 raised to the what? Negative 27. Okay, multiplied by 1.433 times 10 raised to the power of 7, then raised to the power of what? 2. Raised to the power of 2. Okay, now let's get the value for 1.433 raised to the power of 2, and that will be 2.05. So we have 1/2 multiplied by 6.7 multiplied by 10 raised to the power of minus 27, then multiplied by 2.05. Now we know that when we raise 10 to the 7th power to the power of 2, it will be 10 raised to the power of 14. So that will be multiplied by 10 raised to the power of 14. Now, now let's multiply 2.05 and 6.7. So when we multiply 2.05, okay, by 6.7, okay, that would be 13.74. 13.74. Now dividing that by 2, when we divide it by 2, that would be 6.87. All right, so this is going to give us 6.87 multiplied by, now when we combine the powers of 10, negative 27 plus 14, negative 27 plus 14, that's going to be 13. Yeah, that'll be negative 13. That'll be negative 13. That is minus 27 plus 14. That'll be minus 13. Okay, and that will be in joules. So this is the kinetic energy. Okay, the kinetic energy in joules, 6.87 multiplied by 10 raised to the power of negative 13 joules. Now we're almost there. Now we want to find out, remember, the unit of energy must be in mega electron volts. Now, what is 1 mega electron volt? 1 mega electron volts, okay, 1 mega electron volt. Now, when we say, now, we want, now, in mega electron volts, we're going to have the kinetic energy, okay, to be this value, which is 6.87 times 10 raised to the power of minus 13 joules. That is 6.87 multiplied by 10 raised to the power of minus 13 joules. Okay, divide by 1.602. Okay, multiplied by 10 raised to the power of negative 13 joules per mega electron volt. Okay, joules per mega electron volt. All right, so this is going to cancel out. So we'll be left with 6.87 divide by 6.87 divide by 1.602, and that would be 4.288. That would be 4.288. So the kinetic energy will be 4.288. All right, now the joules we cancel out, so we now have the unit to be in mega electron volts. Now we can approximate this. Okay, the kinetic energy will now be approximated to be 4.3 mega electron volts, and this is the kinetic energy of the alpha particle. So the kinetic energy of the alpha particle is 4.3 mega electron volt, and that's the answer to the question. Thank you.